Hi guys, I found this new toy that I thought we could take a look at. You have one in your castle kit, go ahead and pull it out. So what do you think it is? Some kids think it's a battery, some kids think it's not. We call it a capacitor. From the outside it looks like a cylinder and there's two bolts coming out of the top. There's not much else to know about it. I was wondering what we could do to find out more about what a capacitor does. When I asked the students that earlier today, some students in each class said we should put it in a loop, like find out if it's a conductor or an insulator. And so I thought, okay, could we hook it up in any other kind of loop, I asked. And some students in some classes suggested maybe it's like a battery and it could light bulbs by itself. As we go through this, please keep in mind I'm going to go at a pretty quick pace, but you can pause and rewind if we go too fast. So make sure that you've opened up the document from today. It's Unit 2, Activity 1. And we want to answer the V question, what effect does a capacitor have on a loop? If you have not yet made the predictions on the left-hand side, please do so now. Circuit A is if we hook up the capacitor with just two bulbs in a loop and no battery. Circuit B has a capacitor, wires, bulbs, and also a battery in the loop. Again, please make predictions at this time before we move on. To run the experiment today, the first thing we did was hooked up a testing loop. This is just like when we put the sum things in the loop last week. We have a 3-cell battery pack, positive terminal or red springs here, and the blue bolt or negative terminal down here. We have two bulbs in the loop and I have 4 wires. There's 2 wires connected between the 2 bulbs so we can put the sum things over there. Well, it's important to hook this all up and make sure that the bulbs light and that we do have a closed loop before we start testing the things from the loop today. Well, to test circuit A, we have to remove the battery pack. We just want to have a capacitor, wires, and bulbs. Now, before you put this in your loop, it's important to make sure that we have reset the capacitor. To do that, we're going to take one individual wire and connect it to one terminal, and then the other end of the same wire connected to the other terminal. And if you just leave it on there for a few seconds, we can pull that off and we know we have a fresh reset capacitor ready to run. So let's go ahead and test circuit A. We connect one end of the wire to the one terminal of the capacitor and one wire to the other end. And notice, what did you see? What I noticed is that the bulbs were unlit. This is circuit A. For circuit B, we need to pull the battery pack back into the loop. So I'm going to go ahead and connect one end of the wire to the blue bolt, and on the count of 3, we'll connect the other end of the wire to the red springs. You're watching for the bulbs. 1, 2, 3. Now notice that the bulbs lit, but they didn't stay lit at this time. So I'm still connecting to the red springs over here. The bulbs are no longer lit. So I guess we have to circle yes that the bulb's lit for circuit B, but maybe we need a disclaimer, an adjective. Maybe we should add the word temporarily. Well, in the predictions, it suggested that we hook up circuit B a second time. So that's the battery pack, wires, bulbs, and the capacitor. And let's go ahead and touch B again. 1, 2, 3. The bulbs don't light a second time. And if I do it again, circuit B, circuit B, circuit B, the bulbs are not lighting. So the first time we hooked up circuit B, the bulbs lit temporarily, but not any of the additional times. Next up, they said go ahead and hook up circuit A again. So we removed the battery pack, and we just have the capacitor, wires, and bulbs. And on the count of 3, 1, 2, 3. And again, the bulbs lit temporarily. However, the first time we hooked up circuit A, the bulbs didn't light at all. Let's hook up circuit A again. Nope, you can't hook up circuit A and get the bulbs to light twice in a row. Let's hook up circuit B again. 1, 2, 3. The bulbs lit temporarily. Can I hook up B a second time? Nope. But if I disconnect and go to A, the capacitor can light the bulbs without the battery pack in the loop. So what's happening to the capacitor when the battery, wires, and bulbs are all in the loop together? 1, 2, 3. That's circuit B. If we remove the battery pack, we're at circuit A. 1, 2, 3. We put it in the battery pack, 1, 2, 3, so circuit B, circuit A, circuit B, circuit A, circuit B, circuit A. But you can't do A twice in a row, and you can't do B twice in a row. So when we hook up circuit B, what's happening in this loop? What's happening with the capacitor that the capacitor cannot light the bulbs by itself, all by itself. However, after the battery's been in the loop, the bulbs do light temporarily. So after some discussion with the kids, the students suggested that maybe when the battery is in the loop and the bulbs light temporarily, the battery pushes charge around the loop and charges the capacitor. So that temporary lighting of bulbs with the battery pack, wires, bulbs, and the capacitor, we're going to call charging. When we remove the battery pack and the bulbs light temporarily, so you have a capacitor, wires, and bulbs, we're going to call that discharging the capacitor. This is, in a nutshell, what the students learned during lab today. I hope that helps.